Now, another type of data structure you will learn in the beginning is called a stack. And now we're getting back out of the programming language and back into the working of a computer, because that's where I have seen stacks. And a stack is a method of thinking about how data is organized. A stack is just simply some bytes of data. And there it is in memory, as I've shown it before. It's just a bunch of information. But a stack is basically how we define how we access the data. And so a stack means that we put the data in, and then we put the next piece of data in, goes on top of the other one. We sometimes call this a first in, last out data structure, because think of it like a stack of plates. You put one plate on top of the other, then you go to get them, you take the one from the top, and the first one you put down is the last one you pick up. And so we think of a stack as we put the data down, which is called a push, and we keep putting the data down, and then when we need the data back, we do a pop. And once again, we get the data in the reverse order we put it down. Well, what use is that? Well, it's used extensively in microprocessors for what's called an interrupt. So let's say your program is, I'll just draw some memory here. So I'm just going to draw it as a block. Your program is dutifully going through instructions in memory, and then you press a key on the keyboard. That causes a number of things to happen that I'm not going to explain in detail now, but it causes an interrupt. It tells the processor, hey, stop what you're doing, go find out what key he pressed, and go grab that and put it wherever you're supposed to put it. And so it has to stop what it's doing and go do something else. Well, then it has to go back to where it was. So what it needs to do is take a whole bunch of information, such as where was I in memory? Where's my instruction? So where was my memory counter? Where are those 16 or 32 or 64 bits that tell me where I am in memory? I need to store those somewhere. I also have information in the processor, the status register. I have all kinds of registers in the processor holding information. I got to take all that information and store it somewhere. So I'm going to store it in the stack. So I'll draw it separately here. I'm going to take my program counter, my status register, all my other registers, and push them onto the stack. Then I go do my thing, and I go process the keyboard down here, blah, blah, do that, run the keyboard service routine. And then when I'm done, I do a return from subroutine, and that causes me to go back to the stack and pull all that stuff off in the reverse order, put it where it was, and I pick it up right where I left off. And what happens if I have an interrupt while I'm doing an interrupt? Well, that can happen. Something with higher priority than the keyboard comes along. Can't think of off the top of my mind, except on the Atari computer. The video interrupts, of course, had highest priority because they had to be done at when they were needed. They couldn't wait. And so another interrupt comes that just pushes that stuff on the stack, and it can do it a number of times, and then when it finishes one interrupt, it takes the stuff off and goes to the other interrupt routine, and then when it's finished with that, it takes the stuff off the stack and goes back to where it was, and so puts stuff on the stack and then takes it off in reverse order. So that's the idea of how a stack works. Now, of course, the stack is in memory somewhere. The Atari computer is one I'm intimately familiar with, as I mentioned. Actually, the second block of memory, the second block of 256 bytes was the stack. And the way it's implemented is there's a stack pointer that tells me where I am in the stack, and it puts this information in the stack. And so what really happens is, let's look at that piece of memory. We have a pointer that points to the bottom of the stack, and I put stuff in. So I put stuff in there, and that pointer moves up. And I put more stuff in there, and that pointer moves up. So I've got a place of memory. Let's say it's down here. My stack is down there, so I start putting stuff in, and the pointer moves up. I put more stuff in, the pointer moves up. And then as I take stuff out, the pointer moves down. And so it's just regular memory. It's not something special. I just have a stack pointer that tells me where I am in the stack at that time. It could start at the top and work its way down. I don't know. It depends on the implementation. But that's how the stack works. It's just a piece of memory with a stack pointer, which is part of the processing system. The processor always knows where the stack pointer is at any particular time, and that's how the stack is actually implemented. So it's not some special memory that's first in, last out. It's regular memory, and the pointer points to where it is in the stack.